we are done with that topic. Anything else? You guys have any more questions on this, or should we just proceed to the class? All right. So I think I left off. One thing that I didn't do last class was I didn't talk about RandomWalk, and I didn't talk about it because it's something that can be talked about a little bit separately. When you're talking about simulations of processes, or you're talking about events where you're trying to run a large number of possible solutions, it's often very useful to use something called a random function. And random functions are basically like rolling a dice or flipping a coin. Nothing is truly random in the computer world unless you're doing something with quantum bits or something. So there's no real true randomness, but we have to impose something that looks like randomness. And to do that, we have this concept of this random module, right? And random is something, we can get it in our... and I forgot to, dang it, I forgot to print this out again. So now I'm stuck with having to, when I switch screens, having to know what I'm talking about. All right, so we can come in and we can look at the random function, right? I can do an import random. And I can do, help random, and that's going to give us a lot of stuff, more than we're actually able to look at easily. Right? There's a whole bunch of different random functions, different distributions, uniform distributions, etc. The ones we're going to be most concerned about are random.random, right? Random.random generates a random value. It can go down exactly to 0. It can come up arbitrarily close to 1, but it can never actually reach 1. So it's as close to 1 as you can get in the number of bits we have, but it can't actually reach 1. So it generates something that's half closed, right? It can close it. You can go all the way down to 0, and you can approach 1, but you can never quite get there. And that's, if you just come in and you say... random.random, make a call, you get a number, make a call, you get a different number, make a call, you get a different number, and it'll just continue like that. We also have something called random.randint, and you have to give this a range, so you can say between 0 and 5. And let's do help on that first. And it will give you a random distribution, a random integer in the closed interval from A to B. So it includes both endpoints. And again, this is hopefully uniformly distributed. Right, so you can come up 0, 5, 0, 5, 0, 5, 0, 5, 0, 5, 0, 5. If we wanted to do it between -1 and 100. Right, 62. Or how about -100 and 100? So we get some negative values. Right, 19, -80. Right, so it'll just draw random things. There's another one we can use, and that's random.choice. And that you give it a sequence of values, and it chooses randomly from that sequence. So, for example, one that we may want to do let's say range 0, 10. Right, this will randomly choose out of 0, 1, 2, 3, 4, 5, or maybe we want to do random choice list -1, 1. Okay, so it'll randomly choose values. Now, the interesting thing about random is, like I said, it's not. It's not actually random. So when we're talking about random processes, what we're actually talking about is something that's a pseudo-random sequence. So the thing that's generating the random number, right, random in quotes there, is it generates a pseudo-random sequence. Sequence is very long, but eventually it wraps around. And the key is if you start at the same place in the sequence, you always generate the same values. So we can come in here and we can say random, well, we'll do a help on it, random.seed, and that sets and initializes the internal state of the random. And it can take any type of object, any type of hashable object. You don't have to worry about what that means right now, except to know that lists are not hashable, but strings are, and floats are, and tuples are. Anything that's immutable is also hashable. I think a tuple is. Yeah, okay. So, basically, everything you've learned so far except for lists is hashable and what can be used as a random seed. Now, the key is that once you set a seed, and we'll normally tell you to do something like random.seed, and we'll tell you to give it a value of some kind, maybe 900. Your random calls then start at the same point. So as long as you make the same sequence of random calls, you'll get the same values. So we did random seed 900. I made 3 random calls. We'll random seed 100, 900 again, and we'll make the same 3 random calls, and we're going to get the same values. So what this is going to allow us to do is when we're asking you to do something, if we ask you to do a project, for example, that has a random component, we'll also have you set a seed in the beginning. Yeah, I'm recording, Dimitri. Jonathan, thank you. We'll also ask you to set a random seed, and that random seed will allow us to precisely trace your program so that you get exactly the same output that we get. So random is not magic. Random is just a sequence of values, and the sequence of values is controllable, and you control it by specifying a seed. So as long as after you set the seed, you make the same sequence of calls we make, everything works out good. So we'll do a seed again, we'll do a random, and now if we do a random dot randint minus 10,000 to 10,000, and now we do a random.random again, right? What you're going to see is that actually breaks the sequence. Instead of getting the 0.7575321, we didn't make the same sequence of calls. So there's 2 components to using this. You have to set the seed correctly, and then once you set the seed, you have to make the same sequence of calls. All right? Anyway.
Professor?
Yes.
I just have one question about the, maybe you said this already, but what's the purpose of the 900 that you have in the argument for .seed?
Okay, so we're generating a pseudo-random sequence, right? So it's a sequence, and it just goes for a long period of time, and then it wraps around, okay? The 900 tells it where to start in the sequence. So that provides a fixed starting point. And so long as you make the same sequence of calls, it means that all the values are predictable. Because this isn't a random sequence. This is something that looks like a random sequence when you look at it from outside when you measure its properties. But it isn't. It's deterministic. So if you set the starting point, the starting state of the system, then all of the calls repeat. So setting the seed is how you set the starting point. Okay, so when we're trying to walk you through something, when we want you to meet, when we tell you use this random function and generate the same output that we're going to test you against on SubMITI, this is how you do it. We give you a seed, you set the seed, and that sets the sequence to be the same as ours, so long as you make the same sequence of calls. Okay?
Yeah. Thank you.
You're welcome. All right. So I've kind of I think I've talked mostly about what's there. So, boom, boom, boom. All right, so now the last thing I want to kind of do about this is we talked about a random walk, and normally I type this in front of you, and I make a few mistakes, and things are a little bit funky. But this is some code for a random walk. And so you want to ask yourself what a random walk is. What is a random walk? Random walk is you start, right? This is our main code. Notice we have the little guard here. I should have comments in here, but I ran out of time. We can take, I think I have print position in here. So print position is just a function that's a little utility function we're going to use to print out our random walk, just to make this a little bit fun. But the idea is a person starts in the middle of a platform and they randomly roll the dice, and if they roll bigger than some value, they walk toward the right of the platform, I guess, and if they roll below that value, they walk to the left, or some random way of determining which way they walk. And the idea is, depending on the size of the platform, how long does it take them to fall off. Print pause is probably best demonstrated just by showing you. Like, we could say print pause at location 10, and we'll give it a length of 15. And all it's going to do is it's just going to print a little thing with, here's the 0, here's the n plus 1. If the little person gets to 0 or n plus 1, they fall off the platform, and these little dots are just the platform. So this is the person, this little caret. This is the platform, and these are the railroad tracks on either side. If they fall on there, then they get electrocuted or something. So we're just going to set this up. It's going to be a pretty simple program. We come in, we ask for the length. That's going to be the length of the platform. We optionally set a random seed. I'm not going to set that just yet. We put the person arbitrarily close to the center of the platform, and then we just make this sequence of calls every time through until he either falls off or, well, it falls off either end. We're going to print the position on the platform, and then we're going to use a random function. We can do whatever random function we choose. I like random choice because it means that I don't have to do an if statement. I can just say, give me a random choice between -1 and 1. Either -1 comes out or 1 comes out, and whichever one comes out, I just add that onto the current position, and I've automatically moved either right or left. Right, so you can do this with random.randint. Right, and we can take 0 or 1, and 0 we walk left, 1 we walk right, or we can do random.random, and we can test for pause greater than 0.5 we walk left, pause or right, pause less than 0.5 we walk left. All of those work. Just for sake of time, since we are trying to get through this, I'm going to use random choice. As we said before, random choice will return something from this list, and this list only has -1 and 1, so it's either going to return a -1 or a 1, and we can add that directly onto the position, and we'll go. And then I have this little sleep here. That's just to make this slow enough that we can actually see what's going on, and then we do the print pause. Well, then at the end we do a print pause again to show them having fallen off the track. So we have special cases for falling off in the 0 position or falling off the far position. And we can run this. So let me kind of pull this over. Hopefully this runs. I'll give it a length of 5. Right, so we see here they're right in the middle. There's 2 spaces on one side, 2 spaces on the other side. Then the Dendley third rail, and they just move directly to the 0 side, right? This is 0, this is 6. They move directly to the 0 side, and then they fall off, and they're dead on the tracks, or maimed, or maybe they just jump down into the ice cream cart. I don't know. use your imagination. And we can run this a number of times, and what we'll see is that even though we choose the same values, the behavior of the program varies pretty the behavior of the program varies because all of these choices are random, so we get different values. Now what we can also see is that if we put this in, we put our little seed in, right? And notice that we do the seed at the front of the program. We don't do it within the while loop. This is going to reset the sequence every time it's called and start you over again from the same spot. So you generally want to do this once right near the start of your program. But now if we run it and we give a length of 5, it's going to do the same thing every time, because now we've turned this from a pseudo-random problem into something we can predict absolutely, right? The first step is toward the 0. The next step is towards the 1, or towards the end of the platform. 0, 0, 0, false. And if we change the seed, we change this behavior. So if we change this to 100, we'll change the behavior, and now it'll do something different, right? But it'll do something different predictably and repeatably as well. Okay, so it's still doing the same thing every time. It's just a different same thing. Okay, yeah, and the sleep is so you can see the position changing, and you'll notice we have the flush equals true here, and that's so that each of these lines get printed out immediately when we hit this print statement. If we don't do that, we end up with this being very choppy. We buffer about 5 lines at a time, and you'll get all 5 of them, and then it'll pause, then you'll get all 5 of them, and it'll pause, etc. So this is an example of using the flush equals true to make sure that your output comes out at the time of the print statement instead of waiting. Remember, I keep telling you that if you're putting in debug to see where your program is, you want to put this in there. Otherwise, you could be misled. I'm going to start this up one more time. I think the best that I got on this was to use 65. It fits on the screen very nicely. And what you'll find out is that this kind of meanders in the center for a while. How long it meanders in the center depends upon, well, the random factor. I think right now we have the seed set to 100, so this will always do the same thing. But the person will have a nice long time strolling back and forth, probably talking on their cell phone, maybe doing a little Pokemon Go, and then eventually they're going to take one too many steps, they're going to fall, and they're going to hit their head on the tracks. Anyway, the flush statement again. Remember that when you do prints, let me see if I can do this the right way. Let me take this out. Take the flush equal true out. It's not going to be, you're not going to see the best version of this, but maybe this will at least help you to kind of visualize it. So what flush equals true does is it doesn't actually have any impact on the execution of your program. But you see how this is much jerkier now? We're buffering up about 5, if I'm reading this correctly, we're buffering up about 5 lines at a time, and the program is actually spitting out 5 lines at a time. So instead of printing this line and then printing this line and then printing this line and printing this line, it's going to print out about 5 lines all at once. So you get this jump, and what you see going is you'll see this jumpiness where the program is made progress beyond where you are, and you don't know exactly what iteration you're on. So if you're, for this, it just gives us some visual jumpiness. But let's say we were crashing at a specific part, and we wanted to print counter. And we can say counter equals 0 here. Right? So now we want to print counter every time, and we don't have, okay. So this should cause a crash at some point. And we got to take this out too, because that will flush the buffer. Okay, so now we can come in here, we can do 65, and hopefully we will eventually crash. There we go. So now we crashed, and we can print out pause, and pause is 20. Yeah. The problem is I can't tell what counter. Oh, maybe I can. Yeah. So now it's hard to force this to give you the error. Let me try taking one more thing out. We'll try it one more time. Then you'll just have to go with my explanation. Okay. Yeah. So print it out 99. So anyway, when you're debugging, it's often the case that when you're in a loop and you're doing a lot of work or you have a lot of output, when you put in one of these prints, this print will only come out like every 5 times through the loop or every 100 times through the loop. So it may be the case that if you're looking for a specific value, this may not align with the actual time through the loop. If you put in flush, it's going to force that. And that's really what the issue is, especially when you're debugging on submittee. You want to make sure that if you are trying to figure out what iteration something happens on, that flush equals true will force the update right away. And the reason why we have this, by the way, is that I/O is actually the most expensive part of most programs. So if we can bulk up all the I/O, if it doesn't matter, what we'll do is we'll write this to a buffer instead of writing this directly out to the screen. And then when we get a lot of stuff, we'll put it all out to the screen all at once, and we'll save a lot of time. And your program will run more efficiently. But it does mess up this whole debugging thing. So anyway, there's our random walk, and there's another kind of discussion about flush. The only time you really have to be concerned about it is when you're debugging your code. That one failed fast. Oh, I took this time out. I took the sleep out. There we go. All right, so I'm going to move on from here because we still do have a lot of stuff to discuss, and some of this is actually going to help you in your project. Okay, we've got the flush back in. Everything's working good. Flush is only necessary when you're debugging if you're relying on knowing exactly what iteration, for example, or exactly where in your program something occurred. Sometimes prints that don't have a flush don't show up in the output, particularly when you're running on a Linux box or when you're running on something not this console kind of activity. I wasn't planning on it. It's kind of a fun piece of code, but I'm happy to put it out there. I can put it out on the website. Okay, let's start off with flush is a good way to debug without using the debugger. Part of debugging is using print statements to show the path through your code, and it'll certainly help you out with that. Okay? Get good at using print statements. They're a lot faster than debugging, at least to hone in on where the errors are. Random choice can return 0 if 0 is one of the items in the list. So if we did something like random.choice -1, 0, 1, then 0 could certainly be one of the choices. And if there's no seed provided, then you get some state. I'm not sure. I think some machines may start off when you start the console. They may start off with it at 0 or at a specific value. Others will just pick whatever's randomly in memory. So it depends. You'll generally get a decent behavior. Sometimes it'll be repeatable, sometimes it won't. Okay, so let's start off with Lecture 12. Yeah, we've got a decent amount of time. What we want to talk about today is we want to revisit a few things on ranges and loops. By the way, at this point, let's see. I think this is chapter 9 of your text. So finish read if you are following along in the text. This should finish up chapter 9. So we want to talk about ranges and control of loop iterations. We just want to do that briefly because we've already talked about that. And we specifically want to get into more about nested loops and lists of lists because I think your next lab is my favorite lab, which is the Sudoku lab. And you will need to be very good with lists of lists by the time you get done with it. And then at the end, we'll give you some break and continue to help you control your loops a little better. Let's see, we have this little piece of code, and we know that range generates a sequence of values, and we know that a for loop takes a loop variable and a list or a sequence of some sort. Range is a sequence, lists are a sequence, sets can be sequences. And what it does is it sets I in turn to every item in this sequence. So this very simple for loop should just print out the numbers between 0 and 9. We can grab that. We can pop that down here. Oops, and apparently I didn't grab that. Right, and that just prints out the sequences between 0 and 9. And the things to note is if a range with only one parameter generates from 0 up till just below that parameter. So in this case, it'll go to 9. We can control this a little more by giving it more values. So if we want to control the first value, we can give something like 3, 10. And let me slide this over. Right, and that will generate the values starting at 3 and again coming arbitrarily close to 10 but not ever quite reaching it. And we can even give it multiple values. 423 I think is what we have in the text in the thing. 4 20 and 3, and this will start at 4 and it will walk towards 20. And it'll do it skipping 3 every time. Oops, that was not what I wanted to do. There we go. Right, so it starts at 3. All right, one more try. 3. We'll do 320 by 4 instead of 420 by 3. Right, so we start at 3. We walk towards 20. Skipping by 4. We stop at the last value we get before we go past the 20 mark. Okay, so that's pretty much ranges. And the thing we wanted to point out was that a range is not a list. It's a sequence generator or a sequence, but it's very easy to turn it into a list by using the list call. And in general, we will think of it as a list. By the way, up until Python 3, it was a list. It just generated a list directly. Now it's a generator. Slightly different semantics, or slightly different, semantics. But it can be easily turned into a list. And now we see the same thing we saw before. If we put this into a for loop, right, for I in, we take all the members of this range and we set I to it in turn, and then we operate on I. Okay, let me see. It looks like there may be a couple of questions coming up. Okay, so this if name equals main. When we're talking about modules, right, if you run a file directly, right, when I run this file, right, this code, name equals main, and this code runs, right? This is just an if statement, just like any other if statement. When I import this module, anything outside of this guard runs, so I can put a print statement in here. And let's say we'll print out what the name is. And what you'll find out is when we run this, and I'm going to run it with 5 this time so it goes faster, right? It prints out hello, name is, and when we run it from the file itself, it prints out main. So name equals main. Since name equals main, this if statement evaluates to true, and we execute this code. If, however, we import this, all import does is it actually just runs the code. So we can import walk.py. I'm sorry, import walk, right? It's already imported. Okay, and when we import walk, it just executes all of this code, and it comes down here, and when it prints out, this time name is not equal to main, name is equal to the name of the module, right? And because of that, we don't execute this other code. So it's a way for defining functions in modules that you can then use elsewhere, and then down below you can have code that executes only in the main. A lot of times this would be testing code. Okay? All right.